Okay. So, what I'm about to show you, I'm going to give you a disclaimer. It says I am not responsible for what happens. Okay? Once I show you this.
Show me what.
I am not responsible. Okay? I almost want to make you all sign a waiver that says I understand Mr. Burkham this is a loving environment, but I am not responsible, and nor will I hold him responsible from now until the end of the world.
End of the
So,
world.
What?
Why are you sitting next to me?
So what this is it's called field hockey. It's a FET simulation. And the idea being is that you are trying to get that positive charge into the goal.
Oh, no way.
Wait.
That's so cool.
So, like for example, you can take a positive charge and move it there.
Boom.
Okay?
Straight into the goal.
And then you hit start.
Wait, that's. Oh my god.
No, don't talk.
Bad?
Oh.
No, just wait, listen. That's not good.
Oh.
Oh my god.
Oh, this is like, it's like Rocket League.
This is Rocket League. Bank shot, bank shot.
I should just
This is trick shots with Electron.
So we need to get that positive charge into here. Okay?
Well, we can't. There's a wall in the way.
I know!
Two.
What are we gonna do about the wall?
So, Gavin, where do you
Jump over it.
move that single positive? We'll start with just that single positive charge. Where do
Move
you
it down a
want
little
to
bit.
put it? Down a little
Move it
bit?
down a little bit.
No, move it
Like that?
Like that. And then we're gonna go over it. Yeah, we're gonna go over the wall.
add more charges?
Okay?
Hey, you so control, bro.
Shoot.
Gavin.
We need another positive charge.
We need
I
another
want
one.
one positive.
I want two more positive
No.
charges.
Only one at a time.
Okay,
Up there at the top. Up there at the top.
You know, make it better.
Up.
To the left.
To the left. To the no.
Yo, that's it.
I've been to the right.
Shoot the Electron.
Shoot. Hey, what's this stand for?
Is that
Grave. Wait.
Up, higher.
Higher?
Hey,
No.
No.
The first one
No.
down.
Okay,
There we go. There we go. Yeah.
The first one down.
No.
No.
No. Move the first one
I
down.
move the first
Okay,
one down.
move the first one.
Hey,
Move
the
the
first
first
one
one.
down.
One down.
Wait, higher, a little bit to the right.
Gavin.
Yeah. For
That
sure.
is not you.
That is
Yes,
not-
it is.
Turning off the mark.
Gavin,
Wait
bang.
a minute. Bang. Put some more oomph on it.
Wait.
Negative one.
Move
Down there.
Move the one down where?
Move the first one a bit closer to it. The other one.
Like down below the wall.
Break the
No,
wall.
not that one. No.
We need
Here?
No. Hey, can I come up here?
White friend here.
Yeah, other way. Other left. No.
Other left.
Negative.
The other left.
Right.
Right there?
What are we doing?
Why are we successful?
Big Mike, what are you?
This is not okay.
Air ball.
Big Mike, what are you doing?
Mike, you messed it up.
Wait, get rid of the top. Get me to it. What do you want me to do?
Hey, Mike, listen.
Here, we'll run it. This is what's happening right now.
Bert, move the first electron a bit closer to
Hold
it.
on.
What do you mean under the wall?
Let me through it. What do you want me to do? Shush! Huh? We need to get rid of the top.
There needs to be something else that like kind of like interferes with real electrons.
You gotta get something more specific with something else.
Okay, take a little electron, okay?
Take a negative charge.
Yes, and put it, you see the top of the blue ball?
Yeah?
Move it over?
Which way? Right in here?
Down the wall.
Or that side?
No, right? And like
There?
and down a little bit.
Whoa, we're just gonna hit the wall,
No.
dog.
There? Hit the wall!
We're gonna-
There?
We can just do this.
This is right.
Not
We
gonna
don't
work.
see.
Doesn't know how to use a map.
A little bit higher, look at
Okay.
Move the first electron a bit closer to it.
Yeah. Wait,
Okay, we have too much
we're
work.
Which is
The
that?
positive charge.
The one, this one? Yeah,
Move it a bit
that one.
closer to it. Move it a bit closer to it.
Oh,
Like that. There's so much.
yeah.
one.
Now, why does moving it closer make the force stronger?
Decrease
Let's
the
distance.
distance. When you decrease the distance, the force goes up.
Yeah.
Calm
Whoa,
down. This is
Jason
not that
Science.
serious.
Yes, it
Who
is.
goes
It
behind
is
rules?
serious.
Get in the hole!
No, you idiot!
No.
That's not going. That's not
Get
right.
You're bad.
Do what?
Raise the electron.
Wait.
A little bit?
That's tiny bit. That's tiny bit. Yes, yes, yes.
There?
That's good. Yeah, go, go, go. Wait, okay, move it down. Okay, move it down like 2 pixels. Move it down like 2 pixels.
Can we put it behind the
There?
That's a bit too much.
Put an electron behind the goal.
Oh, put an electron behind it.
Whoa!
Like that?
Yes!
That's cheating.
Wait, down.
We were on the edge.
Back down. Okay, now, that was level 1.
I can do level 10.
That's what level 2 looks like.
Whoa.
Okay?
Whoa.
I have an idea. Now, I'm going to show you a video when I did this with level 2 of the class. We had like an off day and we had some time to kill. So I'm going to show the video of what this potentially looks like. Okay? So
Can we not try it really quick?
Just go.
No,
it
bro.
it took like a half an hour to get that.
No, it won't take
Yeah,
that
No,
we
long.
got this.
we got it.
No, it won't take us that long.
Yeah, well.
Is that our homework, Mr. Burkamp?
No.
It took us like 5 minutes.
Okay.
Wait,
Which one?
Oh.
Mexican?
Gavin, catch the slave up. Hit the ground.
Are you gonna turn in your homework?
Wait, isn't that racist?
What in there?
We know you don't do
homework. Now that's racist.
It makes it an assassination instead of a lynching.
Hey, if you hit the trick, I'll do it.
Wait,
Video about it.
Wait, it's like,
It's because David used to be head chum with the trick shot.
The problem is David doesn't like putting his full name, but the first 3 letters of his first name, last 2. You should do that in real life.
Okay, so this is this level 2. What year is this from?
Wait, I couldn't figure that out.
What is that level 2?
Wait, I gotta take a picture of this.
We couldn't figure that out.
So, here's the setup.
What are we seeing?
So we had, this took forever. Look at all the positive and then they were like fine tuned.
Why is there a
Okay?
Why is
So
there
you got like
4?
3 negative charges here, negative charge here, positive, okay? And then kind of the Sidney effect, we put some negative charges back there behind there. Okay, so you have to watch the path of
Dude, hear me out. Hear me out.
particle.
Man, that's what I was gonna say. Just use the.
All right, you ready?
What?
Oh my gosh, what a shot.
Jesus, Lord in heaven.
Oh.
Where's it going?
It's making a L? It says L.
Whoa! Wait, it's orbiting.
Why is it?
Yep,
Hey, we are always doing
actually 2 orbits.
We're always doing LeBron.
Yo.
Bro, what the heck? Where does it go though?
What?
So yeah, so that was the most shot we
Mr.
ever pulled off.
Mr. Burke, you should do that in flex.
And that's what I said, that took like a half an hour.
Yeah, do it in flex.
What does level 3 look like?
Huh?
Yeah.
Can we see level 3?
Get it.
I
Yeah.
am scared of LeBron's legacy.
I just wanna see what level 3 looks like.
I just want to see it. We don't have that data.
Let me switch back over this.
It's just something that
Ronnie might. I know, I think this is off. Like that? Oh, how many?
So level 3, is that.
Dang.
Oh, that is
Oh.
beautiful.
I think
That looks so pretty.
We got that, Berg.
Bergen, we got that.
Berg, we got
You
that.
go like, yeah, it's,
Berg,
I've never even tried number 3.
can we try
We
that
got
in Flex?
If you want to,
I bet.
okay.
Hey, just download the simulator.
Yeah, it's just, you just have to Google FET Field of Hockey.
If I come back with it done, 5 points credit
On a test?
No.
Oh no,
On
we should.
the
on
test?
assignment.
Can we get some texture credit?
No.
No, because
Why?
we're gonna just look up YouTube videos.
Yeah, exactly.
You can't YouTube that, bro.
Yeah, I
No,
guarantee you.
how do I do this?
Okay.
If I make the Mona Lisa in that, will I get extra credit? Yes.
Oh my god.
Okay, how do I get a proton to draw a Mona Lisa?
Basketball. Bet. I'm gonna get a grab. Bet electron. Bet electric field, bro.
Nice.
Yo, I called it. I called it.
Fred has everything,
I
dude.
called it.
Mr. Berg, does Fred have like almost every diagram?
And they still got it.
They used to have a lot more.
What happened to the rest?
Well, part of
Just
it
like
is like
this.
programming
Like
and having it match up with like the new operating system.
like Adobe and stuff?
Okay, so, this game's still going.
Yeah.
Okay. All right, so the lab that we're gonna do, we're gonna start today, we'll finish up tomorrow.
Bro, Shaq. What, Dave?
I'm
Yo, this is all me. This is all me. It's always all you. It's always all you.
Hey, Shaq, come on.
This is why we have an inside.
See, but here's the problem. Now, when I look this way, your other compatriots in crime realize that I'm looking. And they shut
I
up.
have to look this way, so it's not bad.
And you don't buy that clue.
You don't have
And then you keep talking,
No, when I'm looking this way.
and then
Well,
you're
here's
the
an
one
idea,
who's
look
hung
the
out
other
to
way.
dry. So, you're just continuously getting framed.
I think that's really 9 out of 10. 9 out of 10.
9 out of 10.
9 out of
Berg,
10 on the next homework.
Berg, I missed out, man. Where is he?
Yeah, that's higher than most of my homework grade.
All right, anyway, so let me explain what's going to happen with this lab. So we've got some new equations and concepts that we need to talk about. So what you can do is you can drag, like for example, a positive charge.
Right.
Okay?
Whoa.
Dude.
Whoa. Now,
Yo.
so here's this. Let me explain what this means.
Dude, that's beautiful.
So what these arrows are showing is the direction of the electric field. Now, there's a couple of things that are cool about this program. Number one, visually it shows you the intensity of the electric field. Like
Yes.
when you're close to it, it's very, very bright red, and it fades out as a function of distance. Okay? The other thing is the arrows. So what the arrows are doing, arrows are showing the direction of the electric field. Now, listen to me very carefully, Gavin.
Right.
An electric field is defined by what a positive test charge would feel. Okay? Listen to me. It's defined by what a positive test charge would feel. What I mean by a positive test charge is that imagine that I could take some positive charge and put it somewhere in this region. So the reason that the arrows are pointing away from that positive charge that's at the center, and that Q is what's creating the charge. That those arrows are pointing away from it because any positive charge placed in that field would feel a repulsive force. So the direction of the electric field, listen to me, is defined by what a positive test charge is going to feel. Okay? Now, if I swap that out for a negative charge, and I put a negative charge out there,
Yo.
Inward.
That's
Going inward.
That's
Inward. Why?
One arrow.
because it's attracted to the positive charge.
Because
Positive
a positive charge, a positive test charge will feel
Attractive.
attractive. Okay, cool.
I don't like it.
Now, we're gonna go back, put that positive
What's
test
that
charge
sensor?
in. Now, you want to turn on the grids because what you want to be able to do is measure distance. So if you turn on your sensors, you can have this little deal here. What this is measuring
Volts.
is voltage, for those of you that are in AP chemistry.
Oh.
Voltage is joules per coulomb. So voltage is a measure of like potential energy. So for those of you that haven't heard this in AP chemistry, so volts are joules per coulomb. So this is energy per unit of charge, okay? So you can somewhat make the analogy that if I take a 1 kilogram mass and I lift it, that's like joules per kilogram, okay? So that's how much energy that there is stored per kilogram that I lift up. Volts is how much energy there is per unit of charge, okay? Now, so a couple of things. Notice that as I move this closer,
Skyrockets.
voltage gets much higher, okay?
That's beautiful.
So what does that mean? Is there a direct or inverse relationship between voltage and distance?
Direct. I'm kidding.
Diagonal. Final answer.
Inverse.
Inverse relationship, right? Now, interesting thing happens. If I swap that out and I put a negative charge in there, voltage now becomes negative values, okay? So what that tells you is that voltage changes depending upon what is at the source. So let's go back to a positive charge. So if I come up here and move this, what I can do is I can take this tape measure and I can measure like a distance out. So I can take this and drag that out, okay?
What do you need to scale, bro?
So what this means is if I move this, kind of get that lined up, okay, is that 2 grids, yeah, it's basically a meter, okay, or 1 grid is a half meter. So you can use that to measure distance. So also notice that the charges are in nanocoulombs, right? That's going to give you the value of that charge. That's going to be 1 nanocoulomb. So there's a couple of things you can do with this. You can use that to measure distance. You can also measure what the voltage is. Now, you can also, if you hit this pencil line, that draws a line of equal potential, okay? So every point on that circle has a value of whatever that is. So in that situation, that was 9.4 volts. If I plot that again, it goes to 5.7.
That's beautiful.
So any point on that line has a certain voltage. Okay, it's called a line of equal voltage. Now, if I drag this sensor out here, okay? So what this sensor is telling me is the value of the electric field. So if you look at those two meters about a little bit, so that's a little bit easier to see. Okay? So, again, so the negative 6.2, that tells you the angle. In this one, they don't go from like 0 to 360. So that negative 6.2 just means that it's below that x-axis. Because if I move it up above, then it goes to like positive 16.2.
So it goes to 180 and negative 180.
Yeah. Now, but here's the other thing I want you to look at. That arrow, as I bring it closer, notice that that arrow gets bigger.
Yo.
So what does that tell you? That there's also an inverse relationship because there's magnitude and it's an angle. So whatever that red arrow is a vector or scalar quantity. Vector.
Oh yeah.
Oh yeah.
So notice that that's pointing away from that positive charge.
Yes.
So if I get rid of that positive charge
You have -1.
and I put a negative charge in there, notice that that one points towards it.
Bert,
Okay?
put them together.
Yeah, let's put a positron in.
Does it make purple?
Oh, you did. Yeah. Yes!
Gravitational.
It makes an
Yo.
Now, interesting thing happens.
It makes an
Magnet.
It's not a
I
magnet.
saw this in Kentucky.
That's
I know.
north and south. So if I put a positive and a negative in there, it is interesting. look what happens. If you're to the left, the arrows are pointing towards that negative charge, because that's the direction of that field.
Yes.
But if you're by that positive, it's pointing away from it.
Mm-hmm.
So if you were to put a positive test charge in the middle, what would it do?
It'd stay in the middle.
No, we go left.
It would go.
Wait,
it would
in
go
the middle?
It would go left. Why?
Once it goes red,
Yeah, because if you put a positive test charge, it would be attracted to the negative, but it would be repelled by the positive.
I was thinking about
Wait,
neutral. Sorry,
where can
Mark.
you show us that?
Huh?
Show us.
I don't think you can. Can he? Oh, wait.
So if I put that right in between,
Doubles the magnitude.
notice it gets really, 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 really big.
Why is that the
Okay?
story?
You just
But if I put it over here, it points away from it. Put it over there, points towards it. If I put it right in between, it's really, really big and points to the left. Now, interesting thing happens.
Yeah, this isn't funny. This
So, notice on this line, I'm going to plot that. That's negative voltage.
Oh, it's not a
Okay? Then if I bring it over here,
Positive
plot
voltage.
that, positive.
What do you put it in the middle?
What about that?
Why is that one smaller?
So if I kind of put it right in the middle,
Zero?
Zero.
Anything close enough.
basically I get 0.03. Okay?
Oh!
Yo.
Wow.
Now,
No.
so in the middle, I can basically make that go to 0. But I have a negative and a positive. So it's the only way a negative and a positive can effectively add to 0.
Up and down. If they're the same charge.
Well, whatever they are, they have to add up equal to 0.
What are you
Okay.
talking about, bro?
Now,
Yeah.
but I'm going to do something different. I'm going to get rid of this. Okay?
That's
Move this over here. And now I'm going to put a positive charge up there.
No, it's gonna bounce down.
Okay?
Well, let's see.
That's really cool.
Now, here's the question. Now, look at what I just did. I had a negative and a positive. And I can make that add up equal to 0 in the middle.
Yeah.
If I have two positives, you think that's going to add up equal to 0 in the middle?
No.
No, it gets bigger.
Oh, it gets bigger.
I guess doubles.
Really?
Double it or give it to the next person.
Put it 35. So if it's a positive and negative,
0.
that voltage should add up equal to 0. Now, when I plot that one,
Yo.
Why is one side bigger than the other?
okay, it was just a function of this. That's
Wait,
beautiful.
but wouldn't something to like know that?
So,
Yo, that's like
here's what I want you to look at with these lines. Notice that the lines never cross each other.
Right.
Yo, why do they do that?
Okay? Because even if you have the positive and the negative lines, you have these lines of equal potential. So if you have a positive and negative, one is going to have like a negative voltage, the other one's going to have a positive voltage. So you can never make those lines cross because you can't cross a negative line with a positive line. Does that make sense? Okay? So if I have these positive values, then no matter if I put that in here, all that's happening is that those lines are becoming more and more compact. But now I want to do one thing,
Thank you,
and then I'll turn the news. I'm going to take that sensor, okay, and I'm going to move that, try and move that right in between. So notice as I move them right in between,
You were right.
It goes really little.
No arrow.
No,
Not
it's
which
maximum
one,
voltage, but like
Yeah, if we're just making.
Dude, holy
Nah,
lag.
yeah.
Holy lag, bro.
It's like the battery, but like electricity.
so that yellow dot sensor can go to 0 in between the two positive charges,
Yo.
okay?
That's really cool.
But if it's a positive and negative, the yellow dot sensor can't.
What
Okay?
if you put the sensor right on top? Right on top.
It just kind of goes huge.
Me when I'm weak.
Oh,
Yes, this
So
system is becoming so.
Really, yeah, really, yeah.
Okay?
Me one
All right, stop that camera for a second.
Yeah,